Hi there and welcome. In this video we will explore how we can install custom relationships in our result classes. First of all, as we have explored before, you will see that we already have relationships in our result classes. For example, if we go to the user result, we're going to see that we have the nodes relationship. When you create these result classes via schema loader, the default relationships based on foreign keys and other constraints are installed for you, which is super convenient. However, sometimes you might need a different type of join condition, or you might want to extend your joins with extra constraints. In these cases, the default relationship constraints will not be sufficient, but no worries. DBIx allows you to install custom result relationships that you can define based on your requirements. Now let's see how exactly we can add these custom relationships. Before we begin, I would like to introduce you to this new method which is called search-related result set. Since we are working with relationships, it's a good time to explore additional methods that allows us to query our data using DBIx. Now to search related relationships easily, we can do something like my nodes equals schema, and then we can access the result set, which is going to be our user result. And on this user result set, we can call a method which is called search_related_rs. It accepts three arguments. First one is the name of the relationship that you want to search for. Now on the user result set, we know that we have the nodes relationship, so we can provide that. We can say that we want to search nodes. And what's going to happen behind the scenes is that we're going to join the nodes table on our user table. And in the end, what we're going to receive back is the actual nodes results. Let's see a simple scenario where we're just searching for related relationships. So we can call the all method to just get back everything. And just to make sure that data is returned as expected, we can do something like say current context description on our nodes for all the nodes results that we got. And if we run this with Perl -I, include the libraries, and then we run the script. Oops, so it's going to be script.pl. And you can see that we're getting back all the node descriptions when we're accessing the search-related RS method on the user result set. And just to explore this a little bit further, we can also prefix or Perl command with DBIx_trace as we have done before, so equals 1. We're going to see that we're selecting all the nodes data from the user table because this is our primary result set, and then we're joining the nodes table which comes from the search-related RS method. And in the end, the data that we're getting back are the nodes result instances. Now I mentioned that this search-related RS method accepts three arguments. Now these three arguments are as follows. The first one we already explored, that is the relationship you want to join. In this case, again, we're joining the nodes relationship on the user result set. And the second argument are the where filter parameters. These are the same parameters that the search result set method accepts. So that is search_rs method. So we could do something like, give me back all the nodes where the user ID, let's say, for example, equals 1. If we save this, rerun the script, we're going to see that now we're only fetching back the nodes where the user ID equals 1. And the same for the third argument, such as for the search result set method, we can provide additional filter parameters, where you can use arguments like columns, rows, page, and so on. So we could say, for example, we want to only get back 2 rows, save that, rerun the script. We're going to see that now we're getting back all the nodes where the user ID equals 1, and then we're limiting to 2 rows. Well, that doesn't really matter because in this case we only have one node with the user ID 1. So even though if you're limiting to 2 items, you're still getting back one result. If you check the database on the nodes table, we can see that there's only one entry with user ID 1. Alright, so that's it for the search-related result set methods. Now let's get into the good stuff. This video is all about exploring how we can install custom relationships. And what I mean by that is if we go to the user result, we're going to see that we already have this node relationship, and this was automatically created by the schema loader. And this works fine. We just go use this in the script without any issues. But for example, let's just change this search-related RS to search_rs. Now for where filter parameters, let's provide nothing. And here we say we want to join, or maybe we want to prefetch all the nodes results. So we can say nodes, save this. Let's comment this out because now we're getting back the user results. Maybe let's change this to users as well for sake of consistency. And now if we rerun the script, we're going to see that we're fetching all the user data from the user table and we're left joining all the nodes. Now, as you know with the left join is that it doesn't guarantee that the data has to exist on the table that you're joining. So even if the node data doesn't exist and we're trying to left join it on the main table, which is the user table, you're still going to get back all the users that do not have nodes. What if you want to get back all the users where there exists one or more nodes? Now for that, we would need to use the inner join. Now, if we go back to the user result, we can see that there is no join type specified. Now how we can provide our own join for the nodes that uses the inner join type, we can copy all of this setup that we have here And if you scroll down to the user result, you're going to see there's a line that says you can replace this text with anything that you want. For example, custom relationships, methods, or so on. And the line above that says do not modify this or anything above. And what is going to happen if you modify anything that's above this line, this warning, when you use DBIx schema loader is going to overwrite all the changes that you make for relationships, columns, and so on. So every time you want to introduce something custom, you have to add it at the end of the file. With that said, we can easily remove this comment that says you can replace things here. So that's what we're going to do. We're going to add our own relationship, just going to paste what we copied for the has many relationship. Now the structure of this has many relationship and other join types is the same. So we have the relationship name, nodes that we use to join items such as here through prefetch or join. Then we have the result class name that is going to be produced by using the join. So in this case, since we're joining nodes, DBIx is going to produce instances of this result class, which is node. Now the third argument is going to be the conditions that your nodes or any table that you're joining going to be used for constraints. Such as here we can see that we want to use the foreign table, so this is the node table in this case, and we know that on node table we have the user ID. If we check the database, we're going to see that this is the column that we have. And on self table, we have the ID. So we're using on a foreign table, user ID. And since this is self relationship, which is the user table, we're accessing the ID. And the fourth one are a couple of additional constraints you can implement of how these results are going to be handled. In this case, for example, cascade copy or cascade delete. This is database specific. So for example, you can set up your database in a way where you modify the primary record, you delete it, you update it. And if there are changes that affect other related records, such as if you delete the primary record and you have the cascade delete set to true, it's going to delete all the child records. So basically there are no missing entries where there are required foreign keys. And the cool part is we can actually extend these constraints. Now let's start by changing the name of a relationship. We know that we want to have an inner join, so we can call this nodes inner. And here we can provide join underscore type, and we can say that we want this to be inner join. All right, if we save this, go back to the script. And now instead of using the nodes relationship, which is available by default, we can use nodes underscore inner. If we save the script, rerun it, we're going to see that now, instead of having left join, we actually now have the inner join. When we ran it before, we had a left join, and now this has become inner join. And here we can see that our nodes have been aliased with nodes inner. So we know we're using our custom relationship. You can extend these relationships even further. So if you didn't have only a single key that you would like to join across tables, for example, here we have a single foreign key, which is the user ID, but we might have more foreign keys between tables. Now in the simplest form, we can actually amend this and add additional join constraints. If you just copy this and paste this below, we can say something like, we also want to get back only nodes where on the foreign table ID, which is the primary key, equals self ID. I know that this is a little bit silly example, but as I said, we don't have more than one foreign key, so that's going to suffice. We just want to see that we're now applying two join conditions on our foreign table, which is the nodes. Now, if we rerun the scripts, we're going to see that now we're joining on two conditions, where it says the node ID has to be equal to the user ID, which is the second relationship that we introduced, and the node inner user ID has to be equal to the user ID, which was the first relationship, and which makes more sense. And you can add more and more relationships as needed. Now, one thing is that you cannot introduce values in the simple form. For example, where you say foreign key ID equals 1 or there's a specific string. We're going to take a look at this a bit later on. But for now, let's explore additional scenario where you might not want to use the AND condition, but you would like to join a foreign table and use OR condition. What I mean by that is we can say where ID equals me ID, and instead of AND, we want to say OR user ID equals me ID. How you can do that, you can simply provide the third argument as an array ref, and here you can copy the conditions that we had using the AND relationship and provide them as anonymous hash refs. So if we do that, and we also introduce the same pattern for the second condition, we copy and paste this here. Now let's just comment this out for the time being, and let's rerun our script. Looks like there is a syntax error, and yes, of course, we're missing a comma over here because after that we have port parameter with these extra join types. Now let's rerun the script again. And what we're going to see is that instead of using the AND condition, our DBIx is providing the OR keyword. So basically we're joining all the nodes where the node's user ID equals the user ID or the node's ID equals the user ID. Now, these are two ways how you can provide these conditions in a simple form, where you basically have access to these foreign and self aliases, and you can join specific values between these tables. I did mention that there's a caveat. So if you would like to use hard-coded values such as foreign ID equals 1 or a string or whatever, you can't really use this simple form, but no worries at all, because you can also provide a subroutine as a third argument, where you're going to get a hashref args. And in this hashref, we're going to have a couple of things. One of the probably most useful ones is that we're going to have the alias of the current table and a foreign alias that we want to join. Similar that we had with the foreign here and self here, but now we can actually access them differently. And we can extract them from this hashref. In order to do that, we can say let's say self underscore alias and foreign underscore alias. And here, we just want to use a hashref destructuring. So you can say args, then provide a list of values that we want to fetch from this hashref. So we are only fetching values for the keys that we're going to provide in the list. So the keys we're going to have is self alias and foreign underscore alias. And here now, we want to return a hashref. Now in this hashref, the same as we provided relationships here, in the basic form constraint, we can provide key and value pairs on how we want to join the nodes table. So we could say something like foreign underscore alias dot user ID. So we're just going to replicate the simplest form that we have above, where we're just joining the nodes based on the user ID. So we know in a foreign alias, which is the nodes table, we have the user ID. Then you have to use this keyword, which is called ident. And that only means that anything that we're going to provide for this column has to be interpreted in a raw form. Otherwise, if you just provide a value as it is, for example, if you just remove this and say ABC, it's going to be taken as a direct value and escaped. So we don't want to use that. So we want to have this form where it says ident, and there we can say self alias, which is the current user table, ID, and that should do it. And if we now rerun our script, yes, I can already spot it. This is the same issue as before. We didn't add comma. All right, and let's rerun this again. We're going to see that our inner relationship works as before. We're joining the nodes on the node's user ID equals user ID. Now this becomes very useful because, as I said before, you cannot use hard-coded values when you're using the basic form. With this form, you can use values such as, if you check the nodes table, you could say we only want to introduce nodes where importance equals 1. So let's do this. We can do the same form as before. So foreign underscore alias dot importance. And here we can say importance 2. If we save that, we run the script, and now we're going to see that we are joining onto the node's importance equals 2, which is our bind value, and also where the node's inner user ID equals me ID. And on the same note, if you want to use the OR condition instead of AND condition, instead of returning hashref, you can return arrayref. So if you change this to arrayref, and then we provide our conditions as we did before, so introducing 2 hashrefs, so that's for our first condition. Then we copy the second condition and add this as a second element over here. And let's comment out what we returned before introducing arrayref. Save this, rerun the script. We're going to see that now we're joining with our custom relationships, and instead of using AND keyword, we're using the OR keyword. And of course, you're not limited to only using 2 fields. You can add as many relationships as you want here. You can add different type of fields. They don't have to be foreign keys. You can use direct values as we did with this numeric one, or it can be something like ABCD, so on and so on. And just note as well, you can introduce as many custom relationships as you want. You can expand on the default ones. Of course, you can change that. So anything above that is this line that says do not modify is going to get replaced when you regenerate your schemas. So just leave it as it is. And if the default relationships provided by DBIx schema loader doesn't suffice, just add your own. Expand on those conditions, change the join types, and add constraints as necessary. Alright, so that's it for this video. We explored how we can use search-related RS methods to quickly access related results, and we also explored how we can introduce custom relationships, how to define them, name them, and how to expand them. For example, if you want to use AND or the OR keyword to join your relationships, and so on. I hope you found this video useful, and I'll see you at the next one.